Marhaba. Okay. So this session is about sequences. We want to talk about structures in mathematics called sequences. Okay, intuitively speaking, a sequence is just an ordered list of objects. And this list could be finite or infinite. For example, look at the list of all primes. Then the first prime is 2, the second prime is 3, the third prime is 5, and then the fourth prime is 7, then 11, then 13, and so on. Okay, so we want to talk about these structures, sequences. Let us define what do we mean by sequence precisely. So here's a definition. Okay, a finite sequence, we want to use functions to define what is a sequence. Okay, so a finite sequence is a function whose domain is the set 1, 2, 3 up to n. So is a function with domain this set 1, 2, 3 up to n, where n is a natural number. Okay, given by, say, the function name is f of k is, okay, so if you choose k in the domain, so k is a natural number between 1 over n, we say the image is, say, a sub k. Okay, so this is what is a finite sequence. Okay, so why this function gives us a sequence, what is a sequence? We want it to be an ordered list. Look, this is the domain of the function, and this is the codomain of the function. What is the domain? It is the set containing 1, 2, up to n. Okay, and what is the image of 1? It is a1. What's the image of 2? It is a2. And the image of n is an. So if you want, if you look at the range of the function, then the range will be the finite sequence a1, a2, a3 up to an. Okay, so this is what is a finite sequence. If you want, to us, the sequence will be the range of a function whose domain is 1 to n. And these a1, a2 up to an could be numbers, could be people, whatever objects you are listing. Okay, so we want a sequence to be an ordered list of objects. Okay, so for a finite sequence, we require the domain of our function to be the set of numbers, of integers from 1 to n. Now, what is an infinite sequence? So an infinite sequence is again a function. An infinite sequence, okay, is a function, let's call it f again, whose domain is the set of positive integers, which means the set containing 1, 2, 3, 4, 5, 6, and so on. Or sometimes we consider functions whose domain is the set of natural numbers. Okay, again, given by, say, f of k is ak. So if, again, so what is the set of, the domain is the set containing 1, 2, 3, and so on. So we look at the images of these. So we look at f of 1, we look at the image of the next element, f of 2, f of 3, f of 4, and so on. So if we call a1 f of what is f of 1, we denote the image of 1 to be a1, the image of 2 is a2, the image of 3 is a3. In general, the image of k is ak, and so forth. So what is this? This is, we call it the kth term of the sequence. And what is this list? So let me see, put it. This list is, we are listing the range of the function. The range of f, right? So to sum up, to us a sequence is just a function whose domain is either from 1 to n, or for finite sequences or for infinite sequences, the domain will be the set of positive integers or the natural numbers. Okay, so let's take an example. So let's look at an example of a sequence. So consider the infinite sequence, which is given by 2, then 5, then 10, then 17, and then 26, okay, and so on. So usually, let's use the letter small a to denote k to denote the nth term. So the 2 will be the first term, let's call it a1, 5 is the second, a2, a3, and so on. So in general, we denote this whole sequence, we can write this notation. So between round brackets an, to mean that this is a sequence whose nth term is denoted by an, and this is the sequence. Okay, so this means that a1 is 2, a2 is 5, a3 is 10, a3 is the third term in the sequence, and this is the third term in the sequence, and so on. So notice here that there is a relation between the position of the term and the value of the term. So notice that here an is, can you find the relation between a1 and 2, a2 and 5, a3 and 10? You can check that the relation is n squared plus 1. Okay, so what's a3? You square the 3, you get 9 plus 1, 10. a2 is, so you can think this is the image of the function. So if n, again the sequence is a function, and f of n is an. What's an? It's the nth term, and the nth term is equal to n squared plus 1. Okay. So now we want to study two kinds of sequences. One is called an arithmetic progression. What is an arithmetic progression? So two special kinds of sequences. What is an arithmetic progression? It's a sequence which has a first element called the initial term, and then to obtain the next element you add a fixed amount. Say you add 4, so you start with a number, and then to get the next one you add 4, and then to get the next one you also add 4 to the current one, and so on. You keep adding the same amount to every element to get the next element. So this is a definition. Let's say let A and D be any real numbers whatsoever. Okay? Choose any two real numbers, A and D. Then the arithmetic progression and arithmetic progression, okay, is a sequence of the form. Again, what is a sequence? It's an ordered list of elements. What is this sequence of the form? So let me tell you, this is of the form. The first term of the sequence is A. Then the second one is we add D to A, so we get A plus D. And then we add D to A plus D, we get A plus 2D. And then we add another D to the current one to get A plus 3D, and so on. Okay, so this is what is an arithmetic sequence. Okay, now let me tell you, what do we call A the first element is called the initial term, and D, the amount, the number we add every time, is called the common difference. Okay, difference. Do you see why? Because if you subtract any element with the previous one, you get D. So A plus 3D minus A plus 2D is D. The difference between this and this is D. The difference between this and this is also D, and so on. The common difference between consecutive terms is D. So if I want to see this as a function, this sequence as a function, then look at the function f, okay, from the natural numbers here, so starting from 0 to the real numbers, the codomain is the real numbers, where f of n is equal to a plus nd. You see this? So let's see, what's f of 0? F of 0 is a plus 0d, so a, the first term, or the 0 term if you want, is a. Now what's f of 1? F of 1 is a plus 1 times d, which is d. So the 1th term, it's a plus d. And second, f of 2 is a plus 2d. So this is, if you want, this is the number, a is the 0 term, a plus d is the first term, a plus 2d is the second term, and this is the third term. So what is the term at index 3? It is obtained by adding 3 multiples of d to the initial term, which is a. Okay, so this is how you see that this as a function. But what is f of 0? It is a0, f of 1 is a1, a2 is a2, and so on. So this is what we call an arithmetic progression. Let's have an example of an arithmetic progression. Okay. Look at this example, the -1, then 3. So I'm giving you a sequence, and I want you to see that this is an arithmetic progression. Look at this sequence. What is the first term? The initial term a, it is -1. What is the common difference? See, how do we obtain 3? By adding 4 to -1. So here we add 4, and then to obtain 7 we also add 4, and to get 11 we add 4 to 7, and so on. So you see that the common difference is 7. The common difference is 4, and this is an arithmetic sequence because it is of the form of a, and then every step we add d. And so notice that here a k, if you want, is equal to a, which is -1, plus k times the common difference, which is 4. Okay, so this is -1 plus 4k. Look, when k is 0, we get a0, which is -1. Right? And when k is 1, we get a1, which is -1 plus 4 times 1, and this is 3. So this is, okay, so this is a0, this is a1, this is a2, this is a3, and so on. So this is a sequence, but not any sequence, it's a special kind of sequence which are called arithmetic progression. And what is an arithmetic progression? Again, it has an initial term, and every time we obtain the new term by adding a fixed amount, a fixed value. Okay, you want another quick example? Look at this sequence: 7, 4, okay, 1, -2, -5, and so on. So we can call this like B0, B1, B2, B3, and so on. So the first term is 7, and then we obtain 4 by adding -3, and then we obtain 1 again by adding -3, and we keep adding -3 to obtain the newer sequence. So you see here that in this example, the initial term, which we call A, is 7, and the common difference, it is the difference between one term and the previous one. So -5 minus -2 is -3. So here you see the common difference is -3 and the initial term is 7. Okay, so this is what we call an arithmetic progression. Now we want to study another special kind of a sequence called a geometric progression. What is a geometric progression? You start with any real number you want. This is the initial term, and then to obtain the next one, you multiply it by a fixed number, and then to obtain the next one, you multiply what you have now by this number, and so on. Okay, so let's say definition. Let A and R be real numbers. I want to define what is a geometric progression. So a geometric progression is a sequence. So the term progression means a sequence. Okay, so a geometric progression is a sequence of the form Okay, what is the form of a geometric sequence? The first element is A. So remember, A and R are real numbers, and then the second element you multiply A by R, and then you multiply what you have now by R, so you get AR squared, and then you keep multiplying by R, AR cubed, AR to the 4th, and so on. Okay, so this is what a geometric progression is, and notice that geometric progressions have a lot of applications in finance and banking, because you can think of A as the amount you put in your bank and R as the interest that you pay or you get for your savings. And so this will tell you, like for example, this term will tell you how much you will have in your bank after 4 months, or it depends on the period on which the bank is paying you the interest. Okay, so again, how would we think of this as a function? So we can think of this as a function, say f, and has domain natural numbers and codomain real numbers. So the image of 0 under f is A, and the image of 1 is the next one, it's AR. Okay, the image of 2 is AR squared. The image of 3, again we multiply this by R, so we get AR cubed, and so on. Did you see any? So in general, f of n is AR to the n. So if we f of n, what is f of n? In this is the nth term of the sequence, and the nth term is A times R to the power n. So this is the general formula of the nth term of the sequence. Let's have an example and see why this formula holds. Okay, so let's look at this example. So imagine this example: 1, the first term, then -1, then 1, then -1, then 1, then -1. It's an alternating sequence. So is this a geometric progression? Let's see. What is a geometric progression? You start with 1, and then you obtain the next one. How do we obtain it? By multiplying by -1. And then if you multiply this also by -1, you get 1. And then multiply by -1, you get -1, and so on. So it's clear that the first term is 1, and the common ratio, R, is -1. So let me tell you why it's called the common ratio, because R is the division of any term divided by its previous term. Okay, so if you divide AR cubed by AR squared, you get R always. Okay, so whenever you divide a term by the previous one, you get the common ratio R. Okay, so here divide -1 by 1, you get -1. Okay, and see here that an, if I call, so this is say A0, this is A1, this is A2, and so on. So you can see that an is AR to the power n, but what is A? A is 1, and R is -1, and to the power n. And see that this is 1 if n is even, and this is -1 if n is odd. So you see at even places, so at 0, 2, 4, 6 you get +1, and at odd places, so 1, place 1, place 3, place 5, you get -1. Okay, let's have another example of a geometric sequence. Look at the sequence 2, 10, 50, 250, and then 1250, and so on. So here, what is the first term? It is A, and A is equal to 2. Now, how do we obtain the second from the first? By multiplying by 5. And the third from the second, again, by multiplying by 5. 5 times 10 is 50, and then here we also multiply by 5. So you see that the common ratio is 5. And then if we call the sequence whose nth term is Bn, then it's clear that Bn is equal to A, which is 2, times the common ratio, which is 5 to the power n. See, for example, what's B2? It is 2 times 5 squared, and 5 squared is 25 times 2 is 50. So this is B0, this is B1, and this is B2. See, B2 is 50. Every time we multiply by 5. So to get the nth term, you raise 5 to the power n times the initial term. Okay, let's have another example. Look at this. 6, the first term, 2 is the second, 2/3 is the third, 2/9, and then 2/27. Do you see the pattern here? By the way, one definition of mathematics is the study of patterns. What is the pattern here? Let's call the sequence Cn. So this is C0, this is C1, this is C2, this is C3. So C0 is 6, and then to get 2, we multiply 6 by 1/3. And to get 2/3 from 2, again we multiply by 1/3, we multiply again by 1/3, and so on. This says the initial term, this is a geometric sequence whose initial term is 6, and common ratio R is 1/3. Okay, so every time we obtain a new term, we obtain it by multiplying the previous term by the common ratio 1/3, and you start with 6. Okay. So we define sequences. They are ordered lists of elements. We studied two special kinds of sequences: the arithmetic progression and the geometric progression. And now I want to tell you a third way if you want to define a sequence. Sometimes we define the nth term of a sequence in terms of previous terms. Okay, of previous terms of the sequence. So let me illustrate this. So this is called recurrence. Definition by recurrence. When you define terms in terms of previous ones, we call this technique recurrence. Okay, let's have an example. So this example is very famous in sequences. It's called the Fibonacci sequence. Okay, what is the Fibonacci sequence? Look how we will define it. Let's call this sequence Fibonacci Bn. Okay, now I will tell you that B0, so the term at the 0 place is the number 0, and B1 is the number 1, and in general Bn, so, and the nth term Bn is defined to be Bn minus 1. What is Bn minus 1? It's the term in the sequence coming before Bn plus Bn minus 2. So this says that in general the nth term is obtained by adding the previous two terms. Okay, so let's write down what is this sequence. So okay, we know, so this sequence has this form: B0, B1, B2, B3, B4, B5, and so on. Okay, but let's see what are these values. Okay, so this is the Fibonacci sequence. Now, what is B0? It's given to us in the definition of the Fibonacci sequence. B0 is 0. What's B1? It's 1. What's B2? B2, we will use this formula, which is the recurrence formula, to find out what's B2. B2 is B1 plus B0. So to obtain B2, all what we have to do is sum the previous two elements. Okay, so what is 0 plus 1? It is 1. So this is B2. Now to obtain B3, again we sum B2 plus B1. So we sum these two to obtain B3. So 1 plus 1 is 2. Now how do we obtain B4? We need it, B4 is equal to B3 plus B2. So I need to sum these two to obtain B4. And 2 plus 1 is 3, and we keep doing this. Now to obtain this one, B5, you sum 3 plus 2, which is 5. And now 5 plus 3 is 8. And 8 plus 5 is 13. And 13 plus 8 is 21. And you keep doing this. This is 34. And this is what is called the Fibonacci sequence. Okay, so we stop here.